In this video, we'll talk more about the bending allowances and bending table, bending reduction, all those things. As I mentioned earlier, keep an eye on this left tree or the property manager, right? So you will see once I've created some design, two things appear. One is the cut list, another is the sheet metal. Cut list contains all the information related to your sheet metal design. As you can see, it has the base flange, edge flange information, and how it will look like when you flatten it before passing it to the workshop. And the sheet metal contains all the default value for that material, how the end parameters are, bend radiuses are, K factors, and what type of auto relief you are applying. So by making the changes here, you will apply to the whole design in total. Let's say you have multiple designs or multiple parts within the same design space. If you make changes here, it will be applied to the whole or all the connections or the pieces. Now, the first thing that you need to know right now is how this bend allowances work. So we can look into the Wikipedia page for the band allowance information, where it has detailed how they are being calculated. Okay, let's say for example, this for the steel material. Okay, for the hardest one, let's say if we're doing the air bending technique, applying the air bending technique, the thickness K value should be around 0.4. Okay. So, and again, if I will urge everyone to look into different bending techniques from this side. This is pretty detailed, where we have the different techniques like the air bending, the bottoming, the coining technique, folding, wiping, roll bending, and so on and so forth. Okay, so for the bend allowance, we need to know or look into how this design works. Okay, if you remember from our design earlier, here we had this angle here as 90 degrees, and this is what we call the A angle. Okay, as you can see from here. Okay, so let's say if you want to calculate the bend allowance, this A will be that angle, right? We multiply it by pi by 180 to give it transfer it to a radian format. Then the radius will be applied here, how much radius we're applying on the system. So basically this corner, or you can get that data from here. This is the 0.736 is the bending radius, right? And the bending thickness is 107,366, the same value. So R, and then we have this K value here, and times the thickness. The thickness is of the sheet metal itself, and for the case we are working on, the K has been selected as 0.4. So once we put everything on this, we can calculate the bend allowance, and just selecting this bend allowance here, we can just put that number here. Or like I mentioned, for the K factor, what you can do is which is the ratio of the thickness divided by the neutral line, right? So let me start it. Okay, so the neutral line thickness is basically, this is the neutral line, as you can see from the dotted line going through the whole sheet metal, and the thickness is from one edge to that neutral line, and another thickness is the whole thickness of this sheet material, right? Once you calculate that, take the ratio of this small t divided by the big T, and you will get the K factor. That's the simple version. You can go with this complicated version also, which is calculated based on the other parameters we have on the system. Okay, bend deduction is the same, where it's defined between the difference between the sum of the flange length, okay, and also the initial flat plane. So when you flatten the whole design, and you can use this formula for that purpose. Okay, I will ask you guys to explore this Wikipedia page just to get an idea. Just do a quick reading. You don't need to know all the details because these formulas are available, readily available. Okay, and let's see. Once you do that, you can just make the changes for K factor, bend allowance, bend deduction, so on and so forth. For the bend table, that's a different case altogether. You just need to create an Excel sheet or a CSV file with all the information of the bend table for different factors. And once done, you just need to load it by selecting where it is. Okay, I haven't created one for this workshop, but I can certainly send you one, create one and send it to you if you require. Okay. Once you've selected all the parameters and made the changes you wanted, let's get back to the K factor first. Okay, you just click OK, and all the changes you have made will be applied to the material you have here. Just to show you an example of how that bend table looks like is this. Okay, so you have the available units and the bend allowances. Okay, for different thickness of and different angle, what should be the radius needs to be calculated. Okay, also you need to provide the information of, let's say, which material you're using, what are the units. Okay, and once you're done, just save it, and in the Solidworks platform upload this Excel file. That's it. You will be able to apply all those information on this material. That's all for today's video.